Today we'll learn about hosting a static Blazor WebAssembly .NET 9 application to AWS S3 in just under 5 minutes. We'll also enhance this website's performance by connecting AWS CloudFront, which is a CDN service to serve our static website content even more faster and better to our visitors. Hey everyone, this is Mukesh. In this channel, I take complex concepts and try to turn them into simple and actionable tutorials for .NET developers. So if that sounds like your thing, hit subscribe and give this video a thumbs up. It really helps the channel grow and reach more .NET developers like you. This video is sponsored by AWS and I have got something very special for you, a $25 AWS credit that you can claim using the link in the description. Huge thanks to AWS for helping me produce more AWS content for the .NET community. This video is also part of my ongoing .NET on AWS series, where I guide you through building and deploying .NET applications using a range of AWS services. Whether it's hosting web applications, managing databases, implementing CI/CD pipelines, or ensuring scalability, this series provides practical insights to help you effectively run your .NET workloads on AWS. So if you're interested, be sure to follow this YouTube playlist and explore even more in-depth articles on my blog. Let's get started. AWS S3 is a cloud-based object storage solution provided by AWS to help developers and companies by providing scalable and reliable ways of storing data. And previously, I have published a video that helps .NET developers to get started with AWS S3 and manage data using the AWS .NET SDK. So if you're very interested in learning AWS S3, watch that video to get a better understanding. In this video, our workflow is as simple as building a .NET 9 Blazor standalone WebAssembly application, adding a HTTP client that can read data from an external dummy API, and then we'll be publishing it. And once the artifacts are published, we'll be copying over its content to an S3 bucket. We'll also make sure the website is even more performant by adding a CDN layer in front of it so that it's served even more efficiently to the visitors worldwide. As always, here are the prerequisites. You need .NET 9 SDK installed on your machine, an AWS account, even a free tier account would do. You'll also need basic knowledge of how to use the AWS Management Console, and also make sure that your system is authenticated to perform operations on AWS account. So if you haven't already configured your AWS credentials, do watch this video to get AWS CLI profile configured on your machine, which is the recommended way for local development. First up, if you need a static standalone website, probably as a tool to serve some kind of documentation or a simple client application that fetches or posts data to an external API, Blazor WebAssembly is a terrific choice. Blazor is a powerful web development framework that helps developers build high-performance web applications using C#. So if your application is quite static and does not have much dynamic content, it always makes sense to deploy it to a static web host. This is exactly where AWS S3 comes in. Here are the actual benefits of deploying a Blazor WebAssembly with AWS S3. First of all, it's very cost effective. AWS S3 offers a cost-effective storage solution that is also at the same time very scalable. You get almost 5 GB of storage included in the free tier for the first 12 months with almost 20,000 requests. And if you have somehow exhausted your free tier limit, the standard charges are just about $0.02 per GB, which is again very economical. Also, it is very scalable. Both AWS S3 and CloudFront, which we are going to use in this demonstration, are a managed service by AWS and are very scalable. So you don't have to do much work on the service administration part when you see a sudden spike in your website's traffic. Also, since we are using AWS CloudFront, it helps our application to be available in locations all over the globe. This results in faster page load times for your Blazor application. Finally, it's also easily deployable. So if you have your Blazor application developed, it would take probably under 5 minutes to deploy this entire thing. It's also very easy to automate the entire process with some kind of a CD pipeline, maybe something like GitHub Actions. Let's start building our Blazor application. Open up Visual Studio. I'm using 2022 community version. Click on Create a New Project and search for Blazor to load all the available Blazor templates. Here, we'll select the Blazor WebAssembly standalone application. Click on Next. I will name it Blazor Client. Click on Next. Make sure that we are on the .NET 9 version of the SDK, and let's leave everything else as the default and click on Create. Once the packages are restored, simply build the application and run it. So let me build it, and once that is succeeded, let me run the application. As you can see, here is a very simple Blazor application with a counter and some weather data that is loaded from a sample JSON file which is placed within the Blazor project. Now to this application, let's add some API interactivity. So here is a free fake API server that you might already be knowing. I'm going to use the users resource of this particular server for this demonstration. So this particular API returns a list of about 10 users we are going to integrate this API call within our Blazor application. For this, let's go back to our Blazor code and create a new model. So I'll create a new folder called models, and I'll create a new class called user. Which has the properties like the ID, name, username, email, and so on. Next, let's create a service for interacting with the API. So for that, let me create a new services folder. And create an interface called as iUserService. Let me select interface from here and click on add. So this particular interface will have one method signature, which can return a list of users. So let me save this and create a new service implementation of the iUserService interface. Let's add a new class, and this time I'll just call it user service. And I will implement iUserService on this. And let's implement the interface. So before the actual implementation, let's add a typed HTTP client. For this, you need to install a particular HTTP package from Microsoft. Let me right click, manage NuGet packages, and let's search for Microsoft extensions HTTP. I'll get this package installed. And once that is done, let me go back to program.cs to register our actual HTTP clients. So I'll go to program.cs and I'll paste in this code. So this is a recommended approach for building HTTP client applications. So here we can globally set the base address of this particular HTTP client, and this would be used in all the HTTP calls which is coming directly under the user service. Now let's go back to the user service and inject the HTTP client. Let me open up user service and let me paste in the following code, where I'm injecting the HTTP client into the constructor, and in the implementation of the get all sync, I'm using the HTTP client and using the helper method called get from JSON async, which actually returns a list of users. At the API path of users, I will return a list of users, and this list of users will be returned from this particular. With that done, let's add the users razor component to view the JSON returned from the external API in a very tabular format. So under pages, let me add a new razor component called users, and I will add in the following code. So in the code behind, we are declaring a users private field, which is actually a list of users, and that particular list of users will rely on user service that we implemented earlier to get all the users, which in the background will fetch the list of all users from the HTTP API. And finally, once that is done, we will extract the users field here under a for each loop and display all the users one by one. I would probably do one more change here. I'll go into the layout. Under the nav menu razor page, I'll just add a new link for the users. So I'll just copy paste the last navigation menu item. I will name it users and also the path as the users. So this path, whatever you're filling in, should actually match with this one. Let's save everything and run the application. As you can see, we have the users tab here. Let's click on this. And as expected, we are returning the user data from the fake JSON REST API. So now that we have built our Blazor client application, let's publish this application and generate the artifact files that can be uploaded to S3. For this, simply navigate to the root folder of the solution and open up the folder where the CS project resides. So here, I'll open up PowerShell and simply run the .NET publish command, and we'll publish in release mode. So once the build is succeeded, the required files will be available at the bin release.NET 9 publish and this particular folder. So these are the files that we need to upload to S3. Log into your AWS management console and navigate to S3. I'll open it up in a new tab. Now, to get a basic understanding of how S3 works, especially if you're a .NET developer, I have written an entire article where you can work with S3 from a .NET application using the .NET AWS SDK. You can find the link of this particular blog post in the description. Now coming back to the S3 bucket, let's create a new one. I'm going to name mine as Blazor Client CWM. Also, there is one important consideration while creating an S3 bucket that is going to be used to serve static websites. We'll have to ensure that you're creating this bucket at an AWS region that closely relates with your audience. For example, since I am based in India, I can set my AWS region to AP South 1. But for this demonstration, I'm going to keep it as US East 1. You can switch your regions by switching from here. Note that later in this video, we'll be adding a CloudFront CDN to improve the content delivery even more. Also, since this website is going to be hosted for public access, ensure that you have unticked the block all public access. There are other optional additions like adding tags and stuff, but for now, you can go ahead and create the bucket. Note that once we add the AWS CloudFront later in this video, we will no longer need the S3 bucket to be publicly accessible. For now, let's keep it public. And I guess the S3 bucket is already created. Let's click on Blazor Client CWM. I'll open it up. So once a new S3 bucket is provisioned, let's navigate to the permissions tab. Here, we'll have to add a new bucket policy to allow access to the S3 objects of this bucket. This is because we are going to make everything static and everything is going to be publicly accessible. So let's edit the bucket policy and paste in this. I'm going to copy the bucket ARN and replace it here. This ensures that all the objects of this particular bucket is publicly accessible. Let's save this particular policy. And that's all we need to do from the permissions point of view. Now, let's go back to the objects and open up the artifacts that we have generated earlier. So I'm going to select everything and just drag and drop everything here. So just review these files and click on upload. This will probably take around 1 or 2 minutes depending on your internet connection. So now that we have uploaded the required files to our S3 bucket, let's make sure that our bucket supports static hosting. For this, let's open up the bucket and navigate to the properties tab. And let's scroll down to the bottom. You'll see the static website hosting option here. Let's click on edit and click on enable. Here, let's select the host as a static website and I'll name the index document as index.html and the same for the error document as well. Let's save all these changes and let's go back to properties and scroll down to the bottom again. And now here you will see the bucket website endpoint. Let's open this up. And as expected, you can see your brand new Blazor application running full-fledged on S3. So you get the counter, which works, the weather, which as I said before, returns data from a JSON that is actually placed within the Blazor application, and also the users, which actually returns the data from an external API using HTTP clients. So everything working fine as expected. Let's talk about scaling now. Imagine that our static Blazor application gets so popular and starts hitting multiple thousand visitors every single day. Now that we are requesting the files directly from S3 and the fact that our visitors could potentially be from any part of the globe, the rate at which AWS S3 can serve the static website might actually vary. This often leads to increase in delays between requests. We will fix this by adding a CDN layer above our Blazor application in the AWS world. As discussed earlier, let's create an AWS CloudFront distribution for this. As you can remember, at an early point of this video, we have made our S3 bucket public. You wouldn't need this after you put the CloudFront layer. You can go ahead and make the S3 private again. So let me go back to the S3 bucket, click on permissions, edit the public access. I'll go ahead and block all the public access. Let's save the changes. I'll type in confirm and click on confirm. Note that this will make your existing URL invalid and it will probably throw a 403 access denied exception as your bucket is no longer public. So let's go back to the application and I'll try to refresh it. And as expected, we are getting a 403 exception. In this case, you can even go ahead and switch off the static website hosting. So I'll go back to properties. I'll edit it here and I'll disable the static website hosting. So all of this is going to be internally handled by our AWS CloudFront once we have completed the setup. Now, what is AWS CloudFront? It is a CDN service provided by AWS that helps in delivering data at low latency and high transfer speeds. Let's go back to AWS Management Console and search for CloudFront. I'll open it up in a new tab. And let's create a new distribution. And on the origin domain, I'm going to select our S3 bucket, which will be the Blazor Client CWM S3. Under the origin access, select the recommended option. which will be origin access control settings. So for this, you'll have to create a new control setting that will allow CloudFront to actually access your S3 bucket. So let's click on create new origin access control list and click on create. At a later point of time, you'll have to edit the bucket policy again of your S3 bucket and add in a new one that allows AWS CloudFront access. Do not worry, once the CloudFront distribution is completed, you'll be given an auto-generated policy, which you'll just have to copy and paste into your S3 bucket policy. So this is exactly what I have told now. We'll keep everything as the same. Let's set the protocol to HTTPS only. And we'll also name this as index.html. So this is going to be the default root object. So just go through everything, review it once, and click on create distribution. So once the distribution is created, you'll be prompted to copy the generated policy. Let's click on copy policy and navigate back to S3 bucket. Let's go to the permissions, edit the policy. I'm going to paste in the policy that I copied earlier. Let's click on save changes. Let's go back to our distributions. And as you can see, our distribution is still getting deployed. Let's open it up. And this will be the URL of your distribution. So we'll make some quick changes on this. I'll go to the error pages. Let's create some custom error responses to be handled gracefully. Let's create a new custom error response. For 403, I'll create a custom error response. The path will be index.html and the response code will be status OK. Let me create that. And let's create one more for 404, which will again be redirect to the same index.html and give out a response of 200 OK. Let me add that and go back to general. So it took me around 4 to 5 minutes to get the entire CloudFront distribution deployment completed. Now let's copy the URL and open up a new tab and paste it there. As you can see, we are able to load the application much more quicker now. So we still have the counter, the weather controller, and also the user controller, which returns from the external API. The more interesting part is to see the metrics of the CloudFront distribution. So we go back to the distribution that we created earlier and click on view metrics. You'll get to see a couple of nice monitoring metrics that you must be aware of. So this paints a picture of the total number of requests that came in. So I've fired up some around 200 requests in a short time, and also about the data transfers, that is about 7 MB for now, and the error rate that has occurred in any kind of request. Now, talking about the enhancements of this particular implementation, this is already a pretty automated way of serving a Blazor standalone application. The only manual part I see that is that we are actually going to the folder and publishing our application and pushing it to S3. This can also be easily automated by some CI/CD implementation pipelines and workflows like GitHub Actions, where you can automatically publish your Blazor artifacts and push them to the S3 bucket. Apart from this, you can also link an actual domain like a blazorstatic.com with CloudFront URL so that you don't have to use a something.cloudfront.net URL anymore. So when I started working on this demonstration, I had an idea. You can build an entire .NET workload, deploy it to AWS and make it completely serverless. With this approach, you get high scalability, minimal operational overhead and cost efficiency. All of this while leveraging AWS's managed services. Imagine running a full-fledged .NET application. Imagine running a full-fledged .NET stack without worrying about infrastructure management. Let me break down this for you. For the front end, you can use Blazor WebAssembly, which communicates with APIs directly. This can be hosted on S3, like I demonstrated in this video, or also deployed via other AWS services like, for example, AWS Amplify, which by the way, I'll be covering in an upcoming tutorial. The backend can be built using AWS Lambda functions. I've already covered how to create and deploy Lambda functions using .NET in my previous videos. These functions can be exposed via Amazon API Gateway or Lambda URLs, allowing seamless communication between the front end and backend. And for the database or the data storage, Amazon DynamoDB is a great choice. It's a highly scalable NoSQL database, and I have a detailed guide on how to use it with .NET. Now, to optimize content delivery, AWS CloudFront can be used as a CDN, ensuring fast and reliable access to your front end and API responses. For authentication and authorization, AWS Cognito can be a strong contender. It makes it easy to manage user signups, logins, and token-based authentication, which integrates smoothly with Blazor applications. Finally, to automate your deployments, you can use Terraform to provision AWS resources efficiently, and for CI/CD pipelines, probably GitHub Actions can be set up to handle automated deployments. So with this entire stack, you can go completely serverless while building robust mid-scale applications with .NET. So what do you think? Would you consider this stack in your new project? I will probably make a video where I'll build this entire stack from ground up and get it deployed to AWS. Let me know in the comment section if you're interested. That's it for this video. If you guys found this helpful, please leave a like and subscribe to this channel. It greatly helps the channel to grow. I have many more interesting topics coming up on your way. In the next video, we'll learn about how to deploy Blazor application via AWS Amplify. Until then, happy coding and see you in the next video.